So yeah, welcome everyone. I've been attending these meetups like for almost 2 years now, so I thought it's my turn to contribute. And I'm going to pardon?
I agree with that.
Oh, thanks. So I'm going to talk about Ansible, which perhaps is a familiar tool to you, more or less. Maybe you don't work with it, but I guess that you have heard of it. So I'm going to go through it like a quick general introduction, talk about the use cases, where you possibly meet that or see that, and then I'm going to dig a little bit deeper into the Ansible module and what you as a developer might find interesting about it, what you as a developer do if you want to write your own module. So just a short introduction of myself. I know like we still don't have the stuff on screen.
Oh, hang on. Stand by.
I can keep talking in the meantime. So well, most of you have seen me here around. Like my name is Balázs, or like short Bali. It's easier to pronounce and to spell. I work as a software engineer at Red Hat. My actual title is senior SRE, but what we do is just implement the software development best practices to operational tasks. So that's a little bit about me. I've been working with Ansible for years, so I have seen quite a few use cases and traps that you may fall into when working with Ansible. I thought that I'm going through a few topics, so because it's quite a big thing to see all the aspects. So if you feel that there is a question that you want to ask immediately, then please just raise your hands and then we stop, and then I continue with the next topic, okay? Because I'm going through for most aspects of the.
Give me a second, sorry mate.
It's fine. So generally, what I was going to tell about Ansible, and this is what you might hear, is that's the second best tool for any ops job or automation job, and that's actually a compliment, because if you consider the trade-offs of learning the best tool for each task, that would be too much. And most of the things that you can automate, where you can interface with an API, that can be done in Ansible. That's great. Okay, so Ansible is free open source software, which makes it immediately appealing. So no license fees. You can see the code. You can contribute back to the code if you'd like to. That's a versatile automation tool, originally for configuration management. So that was originally designed or written with virtual machines in mind. So accessing remote servers, doing certain configuration tasks on them. That's, as I mentioned, it's open source, maintained by a large community. The core, which is like Ansible core and Ansible, the two parts of the program, that's so mainly maintained by Red Hat. Some contributors, like some maintainers, are outside of Red Hat, but several engineers of Red Hat are paid for basically for working on that. The software is written in Python with all its pluses and minuses, I would say. So it uses a YAML syntax, generally referred to Ansible YAML, but it's just almost like pure YAML. What you do, that's an agentless tool. I'm mentioning this if you might have worked with, for example, Puppet or Shave or SoulStack, then all these tools require that you have an agent on the remote host installed, and after that you can only interact with the remote host. Ansible only requires you to have the SSH port open on the remote host and a Python interpreter. And in some instances for network automation, even the Python interpreter can be omitted. So that's relatively easy to set up. You can see the model, how it works. Ansible, the engine, the software uses an inventory where you group your hosts. I'm going to talk about the inventory and the concept of the inventory in a few slides. And then you access your managed nodes, do your tasks, so log in via SSH, run your tasks, and then it just completes the job, and everybody's happy. I put like an asterisk to Ansible being idempotent, because the idea is that it's idempotent, but because on the other hand it's community maintained, anybody can contribute a module upstream. It depends on the person developing the given module if this module will be idempotent in fact or not. And in some use cases it's not idempotent. So I just stop here for a second and talk about like what Ansible can be used for. Okay, so I mentioned originally that was for server configuration, and this is the primary purpose or primary task you would use it for. But you can then it was extended for network automation, so like automating and configuring network devices. That's a very large field. Maybe as developers you're going to see this to a lesser extent. Ansible can be used for provisioning, which is also like a big field, and that would be probably the most common use case that you use for. So Ansible can be used in tandem with other tools, for example, like with Terraform. You can wrap up the Ansible code into Terraform, or wrap up the Terraform code into Ansible. So use Terraform for provisioning, so like spinning up your hosts, whatever this resource is, and then use Ansible to configure it. Or use Ansible to run the Terraform code, and then in a later step of the workflow you configure your hosts. I have seen this, for example, that's slightly that you have to be careful about if you use it for provisioning, that Ansible doesn't manage state. So if you know how Terraform works, it just is using a state file, and basically the declarative Terraform code is comparing the state file to the actual state what it can fetch from the API, and then it is adjusting. So Ansible doesn't entirely do this. It compares to the actual state of the resources from the API with the inventory that you create. So you have to maintain your inventory, and I would compare, like if you don't maintain the inventory, it would be analogous like you delete something from your Terraform state file. So you can use it for provisioning. The AWS collection is very big and very well maintained. It's maintained by Amazon, so it's improving, but this is something you have to be careful about. You can use it for like automating anything, and I'm going to talk about this when I explain the concept of the inventory. I just stop here, like if you have any questions here, because I'm not going to talk later about like how Ansible works with other tools together. So like if you have anything in mind, like if you're using Terraform or using Packer, for example, HashiCorp Packer, if you know it, like that's used for building, like burning golden images. So like if you work with ephemeral server images, so you're not configure your servers, but just create an image, and every time there is like an update in your software, then you just like build a new image and then just like provision the new image for a server. That's what Packer does. Packer allows you to use Ansible as an executor, and then all the configuration part within Packer is run by Ansible, for example. That's a typical use case. If no question, then I continue. Just shortly, I want to mention something that, like, if you work with more than a few playbooks, then at some point you are likely to use Ansible not just from your laptop or like Rundeck or from a Jenkins box, but either the Red Hat Ansible Automation Platform or its upstream version, the IWX, which is basically like a web application that has like a centralized logging tool and a graphical interface to manage your Ansible workflows. It handles multi-tenancy. It allows you to store your sort of job configuration in a database, and it all isolates the workflows in containers that are called like execution environments for these platforms. I'm not going to talk about the platform in details. If you have questions, I'm happy to answer about that in the end. Like me with my team, we are administering like a relatively decent Ansible Automation Platform cluster, so I have some experience with that as well. So let me just go through like the building blocks what Ansible uses. So, like the smallest thing you can use is a task, and task build of the playbook. And generally, you run Ansible via playbooks. Tasks are actually like modules, so I'm going to talk about more details in that. And you can run modules directly from the command line, but that's like quite like unusual for actual production use. So basically, a playbook is just like a sequence of tasks, and then you give like a procedural like sequence how you want to certain things to be executed. You can use roles, tasks, and handlers. Handlers are special tasks that only run when they get a notification. So I'm going to show an example like how this works. And roles are like a larger logical grouping of like a set of tasks. Roles and modules are generally distributed in collections, and I'm going to talk about the collections as well later, but that is like the distribution unit is a collection. It can contain playbooks, roles, modules, and a playbook can be built from invoking roles, invoking modules in the tasks, and using handlers if it's required. There is a specific configuration file with ansible.cfg. That's not compulsory, so like there will be one in the etc library, like that's like a main configuration file for Ansible, but typically for your repos and larger units of Ansible code, you're gonna have your own configuration file. Here you can set certain things like the callback, so like where you want to get the output in the standard output. You can get like JUnit style output from Ansible. You're gonna set the SSH connection parameters, timeouts, privilege elevation, and other things that you might need in your workflow. Okay. So I hope that it's legible. Here's an example playbook. That's like a very old example. So that's basically using a server, installing Apache as a web server engine. It copies from a Jinja2 template into the configuration file, so configures the Apache itself, and then like starts the systemd service. And in the bottom you might see that there's a handler. So so basically that's an idempotent module. But if it's running and the configuration has happened, so like the configuration has been overwritten or changed, then it notifies the handler and it restarts the systemd service. So I'm just going through the building blocks. On the left side, you can see just like a small screenshot of an inventory. An inventory is basically like a text file where you store the information about your hosts. That's a very basic one. So you can see that there's a mail server, there are 2 web servers, and 3 database servers. And then the playbook is referring only to the web server. So which means that this play is going to run only on the hosts that are in the web servers group. In the top where you see the name, that is called a play. So a playbook may consist of 1 or more plays, but at least 1. You see variables. That is like less common inline variables in a playbook. That's something where you would put only a few variables. Typically, if you have like large groups of hosts with many parameters that you want to configure or keep separate or distinct between, let's say, environments, then you would put this in the inventory in specific files. As you see, like I'm referring to a collection and a module. I'm going to talk about more like that's called like FQCN, so like fully qualified collection name, which means that it builds from the namespace the collection name, and then at the end the module or the role's name. This template module is using to refer to a template that is stored in your also in your repo under files or templates. What I haven't mentioned yet, so like Ansible is in Python, and if you, for example, use Flask, you can select Flask is using Jinja 2 templates as well. So that's the only thing I think you need to learn apart from YAML, like a little bit of the syntax of the Jinja templates if you're using them, and usually at some point you are going to use. Okay, and then but you will see like how a task notifies the handler in case there is a change. So like a task can have basically like 3 outputs. It can be changed, it can be okay, which means like that's the sign of idempotency that it is aware of the configuration that has to be done, but it's already set, so it doesn't have to change anything, or it can be failed. And in case this task is the return code is like changed, then the notification goes to the handler, and then the task that is in the handler is executed as well. So that's just roughly how Ansible runs. I hope I haven't confused you too much yet. Okay, and now I'm going to talk about the inventory. So I copied the definition from the official documentation. So it's like inventory is basically like a list, a group of lists of hosts. But I put a remark there, but basically anything can become a host. So a host, in the original meaning, that was a server, a virtual machine, mainly. But generally, you can use an inventory and store anything as a host. And I'm going to show you this example. So that's quite huge inventory, and you generally use YAML for inventories as well. The original Ansible used like an ini style inventory syntax, and Ansible understands both, and even understands if part of the inventory, when it's like stored in multiple files, is in ini style and the other file is stored in a YAML. Ansible is still able to compile the two into one large inventory and understand all the all the parameters. So as you can see, like it's like a big hierarchy, and each larger group has subgroups which are called like children, and then you give the name of the subgroups, and then I just I collapse it because like otherwise it wouldn't fit on the screen. So like for each group, then you would list the hosts. Typically, if you have many hosts and then you give certain parameters to the host, your inventory, like if you store in one file, that will grow like enormously big. So I just let me just show it in a bit.
You have to make that bigger. The text.
Yes, sorry. Okay. So basically, just these are just small groups, and the Ansible like parses through the entire inventory from multiple files. See if I would see that. So this is how an inventory looks like when you store multiple hosts, and then you just populate all your hosts and host vars into different files. So I'm just going back to the presentation. So this is what would be the general structure. You give one main file that's called a host, where you list all your hosts, and then for each group, the common variables go into the group vars file. So each group vars would, if you can see that like inventory group vars, there's a pre-prod and a prod YAML on the screenshot. Then you would store the common variables in these group vars, and then there's another directory called host vars. And for each host, the the particular variables that are typical only for those individual hosts. This is where you store them. So basically, like an inventory can go very, very big, and that's the logical way. You can even break it up to even more directories and files. After a while, it can become painful to keep track of everything. But you can use the command I've used, like Ansible inventory can parse through it and just give you an output of everything. And you can give certain limits, so like you can just like extract the variables only what you're looking for. So what does it mean that anything can become a host? I'm telling you like one example. That's a real life example. Let's say you need to onboard teams to use a certain platform, for example, or like a service. Then you start treating the teams as hosts. So you get a team, and maybe you have like an LDAP or like a rover, so like a POSIX, for example, group, where you get all the permissions from. They get certain like access rights, and you populate all these variables into your inventory. And then your Ansible automation is onboarding, and just let's say it's a multi-tenant cluster for what you use, or like a developer's platform or like portal, and you need to onboard a new team or create a new project team, for example. Then you just create a new host, new project, give them all the rights, run your Ansible automation, and Ansible will onboard them. So that's, for example, a typical use case. Load balancers for provisioning, for example, like if you create your let's say like public cloud infrastructure, then it's not just servers, load balancers that can be easily treated like hosts, and with all the parameters that you would set. Networking, for example, I've written like module when OpenStack is like a private cloud, like OpenStack firewall rules that call like security group rules, and then how to do batch creation of security group rules. So anything can be treated as a host. So that's what I'm referring to. Some people consider this like as abuse of the concept of the inventory, but it's very useful and very handy. So you don't necessarily have to think about it only for server configuration. Okay, so now we are coming to like closer to Ansible modules and how you use Ansible. The task is basically it's the smallest building block of a playbook. That's a module, typically with all these specific arguments that you pass into it to be used. If you see, and I'm going to repeat this. If you go online and look for tutorials and articles about Ansible, you're going to find a lot of older articles when they would just use like yum. So like they wouldn't say Ansible built in yum, which is I refer to as like FQCN, sorry. But recently, if you, for example, using VS Code and using the Ansible plugin, it's just gonna just like not like correct you because you expected to use the fully qualified collection name. So like it's like namespace collection and the module name, and the very same way you would invoke roles if you would use roles in your playbooks. And now I've come to the concept of roles and then the collections. So I've mentioned already, like, so an Ansible role is basically like a unit, like a full program where you group together like your Ansible tasks. Anything can be grouped into a role, and that's very handy, like when you want to reuse the code or when you want to distribute it within the company or upstream and for the entire community. So you might be wondering why would you prefer a role over a playbook, because generally like a role is a sequence of tasks and a playbook is a sequence of tasks. A playbook is always referring and mapping the task to particular hosts. So you won't be able to create a playbook and run it without defining the host that it is running against. A role can be just written and then can be used against any number or any host, basically where the relevant modules run. That's one very good reason to use roles. The second is what I mentioned for distribution. So if you would like to, your company uses a certain architecture, for example, bootstrapping servers could be created a role, and anybody within the company can use it, and you can easily distribute it in a private automation hub via GitHub or GitLab, or you can contribute to upstream and it can go to Ansible Galaxy. Earlier, you would have been able to create standalone roles and contribute to Galaxy. Now Galaxy is exclusively using the concept of a collection. So like a role has to be part of a collection, and that's the way you distribute. And the collection, on the other hand, can contain roles, modules, and playbooks. So it's like a wider concept, but it's not something that you can run. You can invoke a role in a playbook, and it runs, executes. You won't be able to invoke a collection and run it directly. So you have to just repair particularly like a particular module or role from the collection. The main platform to distribute your roles and collections is Ansible Galaxy. That's basically a free repository. You can go online. It has a very useful interface, so like directly links to GitHub, so you can immediately check the code if you'd like to. It gives you examples. It gives you easy instructions for how to use the collections in your code. So I just put this quote, actually it's like what I referred to, like that if you want to distribute your roles, then you have to put it into a collection. I've put here just on a screenshot just a structure of a standalone role. I've written a small one, and I'm going to show you how it runs, particularly not for the roles purpose itself, but for the testing half. Because my main argument why you would prefer roles over playbooks is because playbooks are really hard to test. So basically you have to run it against an existing host or maintain host particularly for that reason. But there's a framework called Molecule, which is basically your testing framework for roles and as such collections. You can define and have like a range of set server test servers for testing, but basically Molecule does it for you. It supports Docker. It supports Podman. If you might recall Dan Walsh's presentation about Podman, and it supports KubeVirt. Do you know what is KubeVirt? So basically that's a way how you provision virtual machines in Kubernetes. So what Molecule does in a few words is that you write your test cases, and then it spins up a container or an ephemeral virtual machine, runs your entire test scenario, and then it's tearing it down. So that runs very fast. Has basically like any framework, it does the scaffolding for you. Like when you run a molecule init, it's going to create roughly the structure that you see on the screen. So then you can add more files, delete it, and also very convenient, because if you work with TDD, then you can write Ansible modules in the same way. So if you look at the screen, like the scenario is in a BOM, you see like the test sequence is like create. It's creating the test instances, be it a container, be it a virtual machine. Converge is just running your Ansible code that is in the roles sequence of tasks. Idempotence is not a compulsory part. I use it. It's basically just running the role once again. So you make sure that it's not making any changes when it's run for a second time. Verify is the test suite actually. So it's running all the. You can run assertions. You can run different. You can put different conditions, whatever you prefer. and then destroy is when it's tearing down the test infrastructure. So I'm not going to very deeply into the details what a role does. Defaults, you can give some default variables, files, self-explanatory hopefully, handlers, I mentioned what a handler was. Meta is basically the data you have to fill in, because this is where you give information about your role. This is how Ansible Galaxy would be able to interpret what collection is a part of, what dependencies it might have, all the maintainers information, all the platforms that it supports. So you have to state if it supports, let's say, like Debian or Windows or Red Hat, like Enterprise Linux. That all has to go there, and it also has to state what version of Ansible is the minimum required to run the role. Okay, molecule. This is where you create like the molecule scenario. Then this is what molecule create is the files I just explained in the test scenario. README is a README. Tasks. This is where you put all the tasks that your role actually executes when it's being invoked in the playbook. So this one has only like one main.yaml, but like typically like a bigger role would have like several tasks, and then in the main.yaml that would be the entry point of your role, and this is where you invoke all the tasks that are written and stored in separate files. Templates, tests, that is the scaffolding when it creates a standalone role. This folder is not necessarily created when you create a role as a part of a collection. So if you are initializing an entire collection newly, then this may not be set. And vars is like it's one more file for variables. But I've put here with an exclamation point, like always start with the latest documentation, because if you go online, there are very good tutorials how to test Ansible roles with Molecule. But generally, and I'm going to mention this again, but Ansible release cycle is like new minor version every 6 months. And particularly Molecule is also like improving and changing very fast. And sometimes just you find an article written 2 or 3 years ago, and you're going to be surprised why the perfect code doesn't work. And then you have to just start digging in the GitHub issues in the upstream repos. So documentation is very well maintained, very good explanations, and like detailed examples how to create your tests. So if you start writing a role, then start with the documentation. I know it's not common, but I think it's
Does that give you any worries with ongoing maintenance? Is there a risk of package compatibility being broken? So you write something now, and in a year's time,
it's deprecated.
It'll be broken.
I believe that's a common feature of software, and particularly Ansible. Yeah. So I'm going to talk about this in a bit. I made a special slide about the pain points, but no, I seem that I've arrived to the interesting part. I'm just wondering, because like I'm talking a lot, and like, do we have time, like 2 minutes for like a molecule test demo? Because then I can show one.
We're okay. Yeah.
Okay.
Is it possible to make that bigger?
Yeah, I'm going to make it bigger. Sorry.
I'll go one more. How are you? Just to...
Yep. Okay. So let me just. Okay, and let's try and make it bigger again. Yeah. Okay, that doesn't really font it. So let me just. That's going to be big enough. Okay, so I just written just like very simple role. I guess you know what is like the /etc/motd. It's basically just the welcome message when you log into like a Linux box on the terminal. Then this is what is being displayed. So that's simple enough that we can run it fast, and we aim to set this message on a test box. So it's really very simple. I'm going to show you my molecule files. So because that's like a local role and it's not not following the full naming conventions, I had to set like a skip list the role name, so the role name it doesn't following the Ansible naming conventions. That is considered the standard right now. And I'm only showing you the test file. So like that's how you would set your test suite. Check file content. You can check, for example, file permissions, and then use a range of to make it a bit bigger conditions. So like there's a special module called fail. So you set a condition, and if it's not matched, then your test is going to fail. So basically, like an assertion, like in PyTest, for example. Debug is another special module which is like displaying whatever you pass into it. So in this test, you check the actual content. So it's a very simple module with a very simple test case, but you can see that how you might build this up, and then like in a TDD fashion, you would write your tests first, and then see it failing, and just like build up your module. So like I guess it's always important to see a failing test, but because when you configure remote servers that may go into production, that's possibly like more important. That's the proper expression for that. So I encourage everyone to use that approach.
Does that run against a Docker image or something like that?
Yeah, that is going like, so I'm running Fedora, so that's going to be a Podman container, but
it runs for real, I mean, rather than just in memory.
Okay. Okay. Oh, sorry. So basically it's creating a container, then it starts running the role against the container, then it's running it again, then it's running the tests, and then it's tearing down the test infrastructure. This is a small module with small tests, and the container that's already like present, so like you didn't have to pull the container. Normally the tests in CI/CD run a bit longer because it means you spin up a virtual machine or a container which is like it's pulling it. So, but you might have like an idea what this does. So. Okay. So now I'm going back to the modules. Basically, this is what you will build up your Ansible task and your entire Ansible code from. So this again says like that's a unit of code that can control system resources or execute system commands. I think that is still like the wording is reflecting the original idea, that is that Ansible is doing server configuration, and mainly it is using the Linux programming interface. So like this is how you like execute system commands. But generally, the module can, where you can access an API, that's a good place to start with a module actually. So this is how I would put this. Ansible modules. Why would you write your own at all? Okay, so that's the first thing. So if you ever try to express conditional logic, for example, or make recursive task and declare this in YAML, recursion may not look good in any language, but in YAML particularly ugly. So that would be one good idea. If you want to implement complex logic, so like if you have seen the test case, Ansible handles conditionals. So you can put conditionals, and you can put filter plugins, so like you can handle complex conditionals, but it becomes very hard to read, and for the same reason it's very hard to interpret or like put a mental model of what the module or the task itself does. Ansible is an abstraction basically, so like if you look at any module and you would check the source code, then this is what it abstracts away from you. So let's say you have to call an API, then there is a module that can access a particular URL and fetch information from that and store it using this register keyword. But to handle this, then you have to like deal with the JSON and JSON's like elements. So this is what you would, for example, put into a module. That would be like a good idea. So not just recursion, but recursion, complex logic. If you have to fetch data and manipulate that data, and that has to be a part of something that generally needs to be automated. So like the rest of the workflow would not be a good fit for a simple script. So it's not just like, okay, fetch the data, like put it all uppercase and just return, then but a bit more complex, then that would be a use case for an Ansible module. Also, if you have to deal with Ansible, then you have to understand that the computation within the module is running as fast as Python can run, generally. So it's opinionated, is it fast or not, but calling the entire code as a module and run it multiple times if you have to parse through like a list of items, then it's definitely going to be longer and more resource intensive and more costly. So that's again a good argument why would you use a bespoke module. So generally, like not just like accessing the operational system's programming interface, but a public API or an internal API, that all could be good. I would say just like where developers use cases, like many of you probably using ServiceNow for internal ticketing systems, for example, or Jira for tracking, and then you can automate and write a module just accessing the ServiceNow API, updating the ticket, and just run that automation without like opening the UI. So you won't have to leave your like IDE or command line. Okay. So how would you start writing your module? Ansible is written in Python, and that's the general recommendation that you write your module in Python. And particularly if you would like to have it distributed and become a part of an upstream collection, then you have to write it in Python because Ansible in some instances supports PowerShell, but generally like everything has to be written in Python to be accepted in the upstream. But if it's an in-house module, then any language you know can be good. It can become a bit like tedious in some instances, but generally you can write a module. I'm going to show you one example, like a small example that is not in Python. Okay. The upstream documentation gives you like a very simple boilerplate. So if you can write a module with very little understanding what Ansible does under the hood. So basically, it gives you like a template, and you just add your functions and handle the business logic, mainly like the pass and fail scenarios, and then the module is ready. That's how a simple module is done. There are like a few compulsory elements, or like I wouldn't even say compulsory, but without this it's not going to be complete. So the code uses like 3 doc strings, which basically is used to create the documentation. For an in-house module, again, it's not really important, but if you go for upstream, then it's a very hard requirement to have like good examples, thorough description of all the parameters and all the return values. So it's all used for documentations, but for some reason the first doc string is called documentation, the second is examples, and return is where you like describe your return values. After that comes your custom module content, which you can write just like this pure functional style, so just like a range of functions, and then you invoke those functions in your your run module function, or you can write it more like an OOP style, and you can create classes. In some cases, if you have like more complex classes, then you would separate, and there's like a module utils library, and then you would create your classes there, and then import the class into your Ansible module Python file. The run module function, it can be called just run, but like the boilerplate calls it run module. This is where basically from the upstream class you invoke the Ansible module, you pass in the arguments, you give all the pass and fail scenarios, so like what your module does, and in which case you exit with a fail, or in which case you exit with a passing return code. And then eventually, like that's like with any Python module or method, you call like you just done the method, like if name equals main, then run the main function. So that's roughly like the structure you would follow. Especially if it's a part of a collection, then you can write tests. So as it is written in Python, tests for modules are run by PyTest, and then you're running your test suite using the unit test and the PyTest libraries, if you're using Python, you're familiar with that. But what I have seen, most cases, the module doesn't get this kind of unit tests like Python unit tests. But typically, the large collections in the CI eventually create what you would call like an integration or end-to-end test. So basically, this module is run against like an ephemeral host, and they check the output and the results in a similar fashion like Molecule does in the verifier scenario. Sorry, here I was going to show you a module. Okay, so basically, that's again like an example module. I don't think you would use this in real life. I've written like a demo playbook is going to run here. I'm just displaying, of course, like a bit of debug messages, and I don't know if you have heard of the setlist.fm webpage. I really like music. I like to go to concerts, and setlist.fm is a collection of like many bands, and people who attended the concerts can submit the setlist that they have seen on concerts. It has an API. You can create an API. So I made up like, let's say like a dummy module. Let me just see it. So like if the so there's a command which is just like displays the documentation, so I'm going to just display it to you. So you can pick an artist, and then if there is an exact match for a band, then it's going to display how many setlists are available on the site. So that's not very dev, not very ops, but it's enough to demonstrate what you would do with a module. This is how you like describe your return values. That's the minimal information you would display. Make it slightly bigger. So I'm rolling down, and I'm showing the same structure that I have explained. So like documentation, examples, and return. I've shown you that. Okay. And then here's where you invoke the upstream code, then do your Python imports. In some instances, like Python doesn't really like it that your imports are not in the top of the file, but that's something particular to write an Ansible module. Then like a range of functions that basically what is like executes. So I have picked just like a use case when it's an exact match of the band name, and then in this run function, you just set all your passing and failing scenarios. So that's a typical as this module exit.json. That's what you have to use. So you can write it nicer, but basically that's like it's just checking 3 scenarios. If it's more than one, then it displays how many. If not, it's like the Ansible module is evaluated if it's changed, if it's okay, or if it's failed. Changed true means it displays when Ansible is running. It says it's changed. If change is false, then it displays okay. So nothing had to be done. And then fail request is like is a fail. Like I don't have to explain what fail is. So that's the code. And I'm gonna just run it for you. So so I already done this syntax check actually, but just that show you like there's a command. So like before you run your playbook and you really want to make sure that I made no mistake, then you can run this syntax check. It surprisingly finds it fine. So now I'm really confident to run it. You possibly have seen a playbook running. First I'm trying to get some from an artist that doesn't exist, so it's expected to fail. I set the playbook to ignore the failures. So like in your playbook you can set different parameters, and if you feel that a task may fail but it doesn't influence the entire run of the workflow, then you can set to ignore the errors. I had to set like 30 seconds pause because it has a rate limit. So like, yeah, if it executes too fast, then if the internet is fast, then okay. And no, like it ran fine. So you can increase the verbosity. So like I'm just going to do it again. So it's for debugging, or like if you want to check the connection, then you can increase the verbosity and it displays a lot more information. For production use, normally you wouldn't do that because the more output you have, the more burden you put on your systems. But for 1 minute then I think it's fine.
Who are you looking at? Taylor Swift?
Motorhead. No.
Bit of a difference there.
That's even in the documentation. The best band ever. So and then it displays more. So it's changed through, and then it displays actually the message from the module. I also made one. So it's just a demonstration that basically you can write a module in any language. The main thing, and so I'm not going to go because like these are basically the two languages I know to some extent. So like I couldn't pick something that used, for example, like in front-end development. But the most important bit is that Ansible handles all the arguments in a temporary JSON file. So basically the key elements are here, that it reads the file context and in parsing a JSON file. This is how, if you use any language, This is how your module, the code would understand the Ansible arguments. So when you create a module and declare the arguments, so if you see where the arguments are declared, that's a structure. Like, so you create your own data structure with the module arguments. This is taking only a single argument. This is called a name. We also like declare a default name. I dare to use Chester devs for the default, and then basically the code reads in this argument in a JSON format, passes it to the module, and executes. So if I'm going back, that's still very nice. It works.
Does everything work on like standard in and standard out, and as long as the output's JSON? How does it?
So the module, the code in the module is generating a temporary JSON file. So the output, it doesn't have to. It can be JSON, but Ansible can. So you can declare different outputs. You can even, for example, if you know like Java and the JUnit, the test suite, that is XML style output. You can declare that, and then you can put like Ansible output to an XML. You just have to declare the location where it would save it. So Ansible doesn't have to put the output into standard output. It can save into a file. So and you don't have to redirect it like. So I could do it like just put like a simple like a Linux pipe and then redirect it into a file. But
so if you create your module and you want it to become part of a task, is that?
like a task is basically a module with the argument specified. So it's in a module you declare like these are the arguments I require for my task to run, and these have to be variable. So you just declare like that. That's like an argument that has to be a string, an integer, a list, whatever, and then the module is taking the exact values for these variables.
Yeah, and then you call that from your task.
Yes.
Yeah.
Yeah. So the task is calling the module.
Yeah.
It's like a program and a process. Yeah, like a process is a running program.
And if the module fails, how does that communicate back into?
So the module fails because the code in the module fails, or the module fails because the module has the logic, because in certain cases you want your module to fail.
And how does it communicate that, through an error or?
That's basically your responsibility what you do. So you can decide. You can take the error and pass it back to your user. You can create a scenario, like for example what I did with the setlist FM. If it fails because for whatever reason, so like the HTTP response is not okay,
yeah.
then what I do is just like I give like a value, and when the main function of the module gets this value, it just fails. So the Ansible, the task returns you like the fail. So you can do it like always exit and then put a 1, so like a non-zero exit code, and make it fail like that. You can make fail with a particular error message. You can.
And in the playbook, you can determine if this happens
okay, then there's a next step. So if there's a task and a task may fail, then there's a closure that you can put like failed when, and you can see it's failed when the return code is not 1, or when what you can do is register the output. So basically, whatever, let's say sometimes there is no module and there is no easy way to write a module, or no one takes the time to write a module, and there is a special module called shell or command for Ansible. So basically you can run like bash commands using this module. You run the bash command, and there's the option register. So register what this bash command has returned, and then in the next task you evaluate and you say like failed when this the standard output part of this registered response is not something. Let's say you are looking for. I can tell a particular example what we did previously. Red Hat Enterprise Linux, the subscription has to be registered. So you are checking if this particular rel host is registered with the, so like it can take updates, like software updates from the page subscription. And you can run this as a bash command, return, it has a specific wording if it's not registered, and if the registration, for example, expired, and then you can decide. So there are like multiple places where you can decide if it's failing. So you can run, the module is running successfully, register the output, and in your Ansible code you decide if it's failed. You can take the module, the source code of the module in Python, for example, and say, I'm taking like the data from the API, and if the response is not this or that, for example, you have to take, let's say, like a post request, and the API documentation says that it's going to return like 2 or 4, for example. And then if the response is not 2 or 4, then you make the module fail in the Python code, for example. And yeah, I was going to run it like just to demonstrate that it's actually running code. Rust a bit faster, but basically just that's it. So it can run, and the only thing you have to do basically, so if I go back to the IDE, is that I'm going to show the make file. So if you see the build, the make build, is that you have to build your, it's a binary, so like it's a compiled language, so like the output is a binary. So you have to build your binary, and then you have to copy the binary output into the directory called library, because Ansible is finding the local modules in the library directory. So yeah, that's basically what I was going to show you about the Ansible modules. And I have a last, okay, it's not, the resolution is not ideal or the screenshot, but I'm going to tell a few words about it. So what are the pain points? Because I think what I have said about Ansible so far is quite good. I mean, sounds good to me. So it's written in Python. So if you ever dealt with Python, then you can easily get into runtime errors. So like sometimes PyTest and PyLint is not going to point out. Conflict with dependencies. That's a big pain point with Python. So let's say you are using 2 collections in your role, in your playbooks dependencies, and one collection has let's say 1.2 dependency of a certain Python library, and the other one says like it's not higher than 1.1. Then then you will have to think about it a bit. Sometimes when you're using plugins, so the filters, text manipulation, then the Python syntax is leaking through. So like you have to understand how Python is handling, for example, strings, or how Python is handling integers or floats. So it mainly holds true that you need to only know YAML, and you don't have to know a lot of programming to work with Ansible, but it helps if you do. The Jinja 2 templates, it's always like a bit of surprise, because like especially when you have to like how many empty lines you're going to have between the templated values and how it pulls in. That probably like depend on taste. Or just hurts the eye sometimes, like when it gets too many empty lines, blank lines between the paragraphs. I skipped the next one because I'm going to talk about more. It's procedural, so when you create your playbooks and your roles, provisioning. That's not going to start creating, let's say, like security group VPC, for example, then it tries to create it and it's going to fail because there is no VPC where it can create a security group. So that's something that you have to be aware of, that it has to be in this procedural order. Um, I've mentioned previously this fast release cycle, and Fran has asked, like, can it happen that you write something and it stops working? Yes, it can. And this is generally not a problem, because if you're a developer, you're expected to maintain your code. The problem comes with Ansible being an automation tool, and most people are not Ansible developers. So like their daily work is not maintaining Ansible code. They are like, let's say, a network team who writing automation for network devices. So they don't think about like maintaining the Ansible code all the time, and every time there's a new release, then they try to test and see and how it works. And for this is a problem. So like, and also if you look at the enterprise Linux, for example, landscape, is that like the big distros, and not just like RHEL, but also like Debian, for example, and Debian-based distros, they're conservative. So like they don't like to put the most recent version of a package. So like RHEL 8, which is still on for I think for about another 6-7 years. This is by default using Ansible 2.9. Ansible currently is about like 2.17. So that's something that you need to like so the upstream release cycle is much faster than the big OS distros follow. So you have to be like good with the balance, how you keep your code. Sometimes if you don't pin the dependencies in your requirements files, then and you just like rebuild your, for example, images that running the Ansible code, then you can run into surprises that like an upstream new release is just breaking everything. So yeah, be careful about it. But I think that's a general Python best practice, that when you declare your dependencies, then you pin like a version at least in the range of versions, or a set version, and don't just let them like always download the most recent library. Variables, that is something probably I think it's generally in wherever inheritance is available, but so I'm not able to make this bigger, unfortunately. Maybe I can make it bigger and like just like a bit. No, sorry, doesn't work like that. But there's like 20. There's the variable precedence in the upstream documentation. It's 22 points. So there's 22 opportunities to overwrite or shadow a variable. And if you are using, and typically after some degree, you will not only use your own Ansible code. You're going to rely on collections, in-house roles. So it's very easy to get lost and don't understand why a variable is not declared, or when you declare your variable, it's not being respected, and the code is still doing something else, or running somewhere else. It's not always intuitive why it is. So basically, you have to learn it or keep the documentation open when you work with that. And also, you can't expect everyone to find out a new variable name. So sometimes you can completely shadow a variable, and then we'll just get into the weeds. So for me, like on a daily work, all other things, you get used to it, but this is the hardest part. So like when you have to debug Ansible code and see how a role is being invoked, and where this particular variable is being overwritten in the inventory, in the role defaults, is this role invoking another role, because that's like the dependency chain is hypothetically endless. So that's the most time consuming when debugging Ansible code. And basically that's, so like I didn't want to end on a negative note, so I put up like a bit of time. I have time for if it became longer than I originally planned, but if you have any questions or comments, then I'm happy to answer.
It's probably quite an obvious question.
Yeah.
But presumably there are modules for like Azure or AWS, so you can use this instead of Terraform. So you could
Yes, you can
build your cloud infrastructure rather than running against Linux.
Yes, and and many companies prefer that because then they don't have to. So first thing is that Terraform state files for many people that's a pain, and that's a very fragile concept. The Terraform state file. So some people say that okay, I take a little more effort and I maintain my inventory in Git, for example, and then I use Ansible. The second thing is that I don't have to learn Terraform and Ansible because I still have, like you can spin up the yes, but in a production environment you very rarely use a virtual machine in the default setting as AWS or Azure offers you. So like you still have to do, and then you can, for example, write automation in Ansible and let your people just interface with that automation. So like you can create a simple. So if you use like Ansible automation platform, it has a concept of service or like AWS, but you can just use like, let's say, like a web form, and then you just submit. Okay, I need a VM. That's the size. That's the security group. That's the region, and all these like 6-7 parameters, and then automation would run it and do it. And then the automation team wouldn't have to learn two syntaxes and two languages. That's also something. So there is like huge collections. Amazon maintains their collections. Kubernetes, there is a big Kubernetes collection, so you can like handle Kubernetes clusters with it. Azure, obviously Google. So that all can be done in Ansible.
Can you test them in the same way with modules? Molecule, or is it?
You won't be so like you won't be able to test your playbook with Molecule. Molecule is to test roles, and so. But this is becoming hard because, like provisioning, you can't really test provisioning against something else because, like, you can't have a Docker container that has the Azure API, for example. So you would have to do sort of like an end-to-end test, and you make sure that you spin up that infrastructure and then tear it down at the end of the test. And typically this is done in the CI of those big, like the upstream collections. So when you look at the code base for the AWS collection, then the CI will have that.
So I work in some environments that I just basically get given a range of IP addresses. I usually deploy things like OpenStack instead, stuff like that. So obviously you can't really deploy them on the cloud or on bare metal. Is there a way of building the host file a bit quicker? So at the moment I'm basically just going through, typing out the IP addresses, giving it a host name manually, and
you can.
But a way of generating all the hosts in a particular range a bit faster.
Yes, basically, like if you don't need a host name, but you need just like a host group, then you can give like a range of IPs and a range of let's say like I don't know what you build in an OpenStack, but let's say like it's just like let's say server 1, and then like there's a syntax for this, like server like 1-10, and then server 1-10 and an IP range. So you can do it much faster, and then the Ansible inventory will understand that. And there is a big OpenStack collection. So I know for a fact because I have contributed backups into that collection too, and I knew two people. They used to be my colleagues, but in different part of the company, who were the maintainers. So that's a big collection. It's a very, very thorough big CI and very well maintained. So and you can use it also, like OpenStack SDK is a very good SDK in Python. So
just figure out wasted a few years of my life trying to do it manually.
I've got to run, guys, but I'll see you in the next one. Yeah. Cheers, guys.
Yeah. So it's probably a stupid question, but is this for provisioning Linux mainly? I mean, you talked about PowerShell. I didn't see any.
So Ansible can handle Linux, Windows, BSD, different flavors of Unix. Not only Linux. So like originally it was only Linux, and then it was extended because Windows is a very good use case. Yeah, like automate Windows servers. So we have like there are in the organization I work, there's a parallel team who are dealing with like automating and dealing with Windows infrastructure, so it can be used.
Would you use this for performance and load testing of infrastructure as well? Could you do things like, I don't even know if it's still a thing, but like Chaos Monkey, where it would rip out parts of your infrastructure and test it again, and be able to do that with it?
You could, but I think that Ansible is not the best tool for that, because it means that, so you have to, so what happens to inventory, that you have to declare certain components of your inventory, and Ansible knows this. So Ansible is not like Terraform, that if you remove something from the state file, then it compares, and the declarative style means that it's no longer in the state file, like, or it's a state file, but it's no longer in the code, I have to delete it, or it's not in the state file, but in the code, so I have to create it. Ansible works, you have to state if it's absent or present, or like depending on the module what it uses, like the latest, or if it's a package. So you could do, for example, if you want to do something like stop a service, yeah. So like, you know that you have a range of web servers, and then you randomly pick one of your servers from your inventory, and then run a command and stop, let's say, stop nginx, like the system this service, and then it is not running, and then you expect something like, and I see like how the entire like the alert system or whatever, like how it will react. You could use it, and this is where I'm saying that it's versatile. So like whatever you can script, you can do it in Ansible. But for I think for this kind of task, that there are like separate tools. It's because usually people who deal with this kind of testing is more on the InfoSec side, on the SREs, that work less with Ansible.
What's the, I mean, I've never used anything like this. Where would you start?
I think if, let's say, because most people really like work with web development, right? So like that would be very good. Let's say if you're deploying in virtual machines, then you could automate like building the images, like the virtual machine images, run from Packer, or you can run like from Ansible, like and then use Relo as builder or something, and then you configure that virtual machine with all the application, set the service parameters, and then create an image. So like provisioning the image, it's like a ready image, you just like to like spin it up. So whenever you create a new version of your application, you just like your CI would build a new image, and then this is what you would use for provisioning. If you put container into containers, you can directly run your container builds from the CI with Docker or Podman commands. But if you have to handle like a lot of environments, for example, and the environments have different parameters, then the inventory would be like a good candidate for like store the different arguments, like parameters for different environments. And there is a very good, it's called Podman, and I think for Docker as well. But basically it can be used for building images, running images, execute, like basically like entering, like execute into the running image, tagging images. So you can manipulate containers with Ansible very easily and at scale. So that could be a use case. Yeah, provisioning like test infrastructure for yourself. So you don't have to start clicking together. I don't know if you like VirtualBox or Vagrant or KVM, like Linux virtualization. Then you could just put everything in Ansible and then like spin out the machine, configure, and use it for local testing. That's for example a use case.
So this isn't a question related to your talk.
Yes.
But you talked about Podman and Docker, and I get a feeling you use it more than often. We had a talk on Podman.
Yes, I know, because Dan Walsh is a distinguished engineer at Red Hat, so like...
Well, what advantages do you see over Docker that Podman's got? How would you use it?
So Podman, the entire toolkit is like Podman and Builder and Scopio. So it's more convenient to deal with containers first. On the OS side, it's safer because Podman is like it's a fork exec model. So and there is no daemon running with elevated permissions on the system. So like the process ID mapping between like Podman means that if you break out a Fortran container, then on the host OS system, the process that is not running as root. So that's a security reason. And for example, with Scopio, like you don't have to pull down images. If you want to retag an image, like in Docker, you like Docker pull, Docker tag, Docker push. Scopio is just like run Scopio copy. It's not pulling down the image, it's accessing the registry and adding the tag in the registry, for example. So like some like convenience bits as well.
Yeah, no, I've started using Podman instead of Docker just to play around and haven't noticed any difference yet. So
most comments are like drop in, but yeah. Some are like if you have to, like for example Docker, if you want to delete more images at once and like force delete, that's not that easy because you have to pass in all the image IDs, and Podman you can just delete all the like remove all the images. So
yeah. Any more questions related to the talk? Thank you very much.
Thank you very much.